Hello and welcome for this video today. I'm going to show you how to name simple straight chain alkenes. Now an alkene is a hydrocarbon. By hydrocarbon I mean a molecule having only carbon and hydrogen atoms that has got at least one double bond. Now a double bond is something like this. And as you can see, a carbon atom has got 4 electrons in the outermost energy level. 1, 2, 3, 4. 1, 2, 3, 4. And so, when they share this bond to form a covalent bond here, they are going to, here they are sharing, each carbon atom is contributing 2 electrons, so that now a pair of electrons is forming a double bond. And then we have these 2 electrons here that can form bonds with other atoms of other elements like hydrogen and so on and so forth. Now this is going to now to be represented in this form here. This is a double bond and this is the potential now of these carbon atoms to form other bonds. Now the simplest alkene is called an ethene. It has got 2 carbon atoms like this and like this, and 4 hydrogen atoms. Now, the general formula for alkenes is written like this. Now, this is a carbon atom. This is the number of carbon atoms, and the number of hydrogen atoms will be double the number of carbon atoms. For instance, for this molecule here, we have 2 carbon atoms and 4 hydrogen atoms. Now, the name of this molecule, because it has got 2 carbon atoms, we'll start with an L. Then, because it is an alkene, we are going to put an E and E. This will be the suffix. So the name of this molecule now will be an ethene, like that. Now, suppose now we add another carbon atom here, like this, and then of course we add some hydrogen atoms, like that. Now you see the number of carbon atoms has changed to 3, and of course now the hydrogen atoms will be double, 1, 2, 3, 4, 5, 6. Because of the number of carbon atoms is 3, so the prefix now will change to prop. Prop means 3. Now this is prop here, and then we have an in there. And now, because the double bond, carbon-carbon double bond is in carbon number 1, starting from the left side here. We are going to put this one here. 1 in means that the double bond is in carbon number 1. So the name of our molecule now becomes prop 1 in. Now, suppose we started counting from this side. It will be 1, 2. It will be in position number 2. But remember that we always put now the number which is the lowest for that carbon in which that double bond is. So our lowest number of carbon in which the double bond is 1. Now let us continue and we add another carbon atom like this to this molecule. And then of course we are going to add hydrogen atoms. Now, this molecule now has got 4, 1, 2, 3, 4 carbon atoms. So the name of this molecule, we will start with a but. But means 4 carbons, like this. And then it's an in because of this double bond here. And then we are now supposed to get the position of the double bond. Now, starting from the left side here, it will be 1, it will be in position number 2. And starting from the right side, it will be also in position number 2. So we put a 2 here. That means that the double bond is in carbon number 2. So if now the name of our molecule now will be but2 in. Now, this one is usually called a structural formula. We can condense this formula further. That is, if we put that one there, we are going to condense this molecule. As you see, this is carbon with 3 carbon atoms. This is carbon with 1, 2, 3 hydrogen atoms. So we put that one there. This is a CH. You see this carbon with only 1 hydrogen there. We put a CH there. We have another carbon with a CH group. This one here. And then we have a carbon with 3 hydrogen atoms like that. And now this becomes the condensed formula for this molecule like that. Now let us add another carbon atom here like this. So this name will obviously change now. Then we add our hydrogen atoms like that. Now we have a hydrocarbon on alkene with 1, 2, 3, 4, 5 carbon atoms. So the name will have a suffix of "in". Then pent means 5 carbon atoms. It's going to replace a but like that. And then we have now to indicate the position of the double bond. Starting from this side, it will be in position number 1, 2. Now starting from this end, it will be in position 1, 2, 3. So we are going to take the row number, which is a 2. So we are going to put a 2 there. And so the name of our molecule becomes pent 2-in. And suppose now we write the condensed formula, it will be CH3 there, CH there, CH there, CH2. So we add a CH2 here, like this. And so now that is our condensed formula for this molecule here. Now, if we count, the number of carbon is 5, so the number of hydrogen atoms from our general formula should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now this now becomes our molecular formula for that molecule. Now this is possible for all alkene. We can be able to write structural formula, condensed formula, and then molecular formula for all the alkenes. And let us look now. Suppose we change now the position of this double bond here, like this. And then we change it to here. Like that. So the condensed formula will also change. So this one, we are going to bring this is a CH2 now. We put it there. This is a CH and this is a CH. So it is going to change. You can see the structure has changed because we have changed the position of this one. But the name, with the name change, we have 5 carbon now, so that is a pent. And then we have, it is an alkene, so this one will remain. And then the position will be 1, 2, starting from this side. When you start from this side, 1, 2, 3, so we put a 2, because we are going to take the lower carbon atom. Now, to finalize this thing, we can go on to carbon number 6. It will be a hex. To carbon number 7, it will be a hept, and so on and so forth, like that. Now, these hydrocarbons, alkenes, usually come from alkenes. They are basically alkenes without 2 hydrogen atoms. Now, let us look at an alkane, which is a pentane, like this. As you see, we have a pentane here. Now, what usually happens, for us to be able to now to form a pentene or pent2-in, we are going to remove these 2 carbons here, like this. And then we put our double bond like that. And the hydrogen atoms here. You see now, these 2 hydrogen atoms which have been left have nowhere to bond. So we are going to remove these hydrogen atoms here, so that this bond will be formed by the original protons which were bonding with these hydrogen atoms. And this is the reason why we say all alkenes are unsaturated hydrocarbons. That is, they have a deficiency of 2 hydrogen atoms, because the electrons that were boarding the hydrogen atoms now are used to make a double bond. And that's why we say all alkenes are usually unsaturated, or they lack 2 hydrogen atoms for that matter. Thank you very much for watching this video. We have seen how we name several or a batch of alkenes, straight chain. We have seen how we make their condensed formula, how we make their molecular formula. Next time you are going to see how we name branched alkenes. And thank you. We meet in the next.